Hello everyone, welcome to our daily physics problem. Day number 41. Yes, we are back. Daily physics problem is back because I'm Chana. So today we have a problem. It's about a ring with radius r resting on a frictionless plane. And a bug with identical mass is moving along the ring with angular velocity omega b with respect to the ring. After the bug completed the circle, what is the center angle displacement of the ring? So I want you to pause the video, try your own. If you try, come back to the video and I want to show you how I did it. So welcome back guys. So first let's see what will happen to both the bug and the ring when the bug is displacing on the ring. So because we know that in a frictionless plane, the center of mass have to be uh, at the same position regardless of the movement because there's no external force acting on it. So the center of mass should be at the same point. And because we know the ring and the bug have the same mass, center of mass will be at the center of the radius of the ring. So uh, so the bug and the ring itself, the center of the ring, will moving according to a circle with a diameter of r with and in this direction because the angular velocity of the bug is in that direction, and the radius of the circle will be r over 2. Then, because we know the conservation of angular momentum, we can lay out this uh, this relationship. So let's move the picture to the left and let's write out our conservation of angular momentum. So we have three terms we need to consider. First is the angular momentum of the entire ring around the circle, and the angular momentum the entire of the bug according to the little circle, which is m r over 2 squared times omega b times m times r over 2 squared times omega r. Then we also need to consider the angular momentum of the ring itself. It's also rotating. So we have m times r squared times omega. Omega will be the angular velocity of the rings itself rotating according to its center. And that will be equal to 0. So according to the angular momentum, and we know two masses are the same. So we know the angular momentum of the bug and the ring according to the small circle should be the same because they are always at opposite ends and the center of mass have to be fixed at that position. So we can just simply combine the two terms. Omega b equals omega r, and then we move mr squared times omega to the right. And we cancel out m, cancel out r squared, cancel out 2, then we will have 1 over 2 here. Then we know that omega b will be equal to negative omega times 2. Negative omega times 2. So now we know the angular velocity of the bug respect to the ring, and we have found a relationship to its original angular velocity of the ring. But that's not a solution. Remember, that's not a solution, because we want to find whether the bug will move according to the ground, not only to the ring itself. So we can assume another angular velocity. The omega naught will be equal to the angular velocity according to the ring of the bug minus the velocity of the ring, because the ring is also moving. That's to the opposite direction of the bug. So it will appear the bug will be faster if you're looking at the perspective of the ring. So then we plug in our negative 2 omega, we have angular velocity of the bug according to the ground equal to negative 3 omega, which means every time the bug complete a circle, the ring completes 3 circles. Will complete one third a circle, 1/3 a circle. So the displacement will be 2 pi, which is entire circle divided by negative 3. and that's our final solution.